This is the engineering concept for you. Please subscribe, like, and share this video. Throttling process. So, what is a throttling process? And this is a diagram of the throttling process. Here, provide a filter. This section 1 1, this section 2 2. This is a inlet, and this is a outlet. Okay. So, throttling process is also called as the irreversible process. Here, the insulation is provided on these devices, and hence the heat transfer rate is 0. So, due to insulating surface, there is no heat transfer, that is adiabatic process, and therefore heat transfer rate is equal to 0. So, in throttling process, we can say this is an adiabatic process. And also, if you see, the fluid is coming into this boundary and going to the outlet, there is nothing boundary change. Okay, the boundary remains its constant position. So we can say there is no work transfer since no change in boundary, and also potential energy is 0 because horizontal duct. So here if you see, the throttling device is in horizontal place. So horizontally place, that means the height of the throttling device surface is nothing but the 0. So 0, that means formula of this potential energy is nothing but the mgh. So mgh, so that means here h is equal to 0 or due to horizontal duct, and hence mgh is equal to 0. That means change in potential energy is also 0. And due to constant boundary, that means there is no change in boundary, so that means it's a work steady flow is also 0. And the velocity at the both section is equal to, that means v1 is equal to v2, that means inlet velocity and outlet velocity both are the same, because the cross sectional area are the same, because the cross sectional area of this device is same, and hence v1 is equal to v2. You know that in nozzle, what happen in nozzle, the cross section area like this is the inlet, this is outlet, so cross sectional area is reduces, and hence the pressure built up at that point. And when the suddenly expand, that time velocity is increases, so that time we can say v2 is very larger than to the v1. Okay, and its reverse operation is nothing but the diffuser. Okay, is a diffuser. So now here area is the same throughout the device, and hence there is not a kinetic energy, we can say, because the change in velocity is 0. And we know that kinetic energy is nothing but what, mv square, and change in kinetic energy is a 0 because the kinetic energy is a constant. So after that all known the values, but we applying the steady flow energy equation. So steady flow energy equation, why we use, we know that according to the continuity equation, the inlet mass and outlet mass both are the same. Okay, at that time we use a steady flow energy equation. So steady flow energy equation, the mass flow rate is constant. Okay, is a constant, and that time we use steady flow energy equation. So this is a q minus WSF is equal to total energy. Okay, so q minus WSF, so we know that the q minus W is nothing but the, in if you see the first law of thermodynamics, so q minus W is equal to delta U, that means internal energy. So internal energy is nothing but the what, total energy. So enthalpy, change in kinetic energy, and change in potential energy. So we put all this given value, assumed value. So adiabatic process, not a change in boundary, horizontal duct, and constant kinetic energy. So when we put all the 0 0, that time h1 is h2 minus h1 is equal to 0, and hence you can write h1 is equal to h2. And we know that the enthalpy formula, enthalpy means what, it's the summation of the internal energy and workflow. So PV is equal to nothing but the what? It's also called as a workflow. So workflow is a summation of the internal energy, and workflow is nothing but the what? Enthalpy. So this U1 and U2 and this P term, workflow term another side. So that means change in internal energy is nothing but the what? V1 minus P2 V2. Okay, and we know that also the change in enthalpy is nothing but the what? mCp delta T. Okay, so according to the Joule's law, enthalpy is the function of a temperature only. Okay, so we know that the H1 is equal to H2. Now we derive this equation, and then Cp also get cancelled, and then T1 is equal to T2. If you see the T1 is equal to T2, that means you can say throttling process is a isothermal process, but it's a totally wrong. Isothermal process, throttling process is not a isothermal process, it's an isenthalpy process. Okay, in many competitive exam they ask throttling process is an isothermal process, but it's not true. So why T1 is equal to T2 but not is a isothermal process? The reason is, if you see in this diagram, okay, so in this diagram what happened, this is the T. Okay, so T1 is changing and going to the T2, or another method, T1 temperature decreasing again built up to the T2. So T1 is equal to T2 at that condition, and in this condition also same, T1 is equal to T2. So it's a isothermal process? No, because temperature is a point function, that is, it does not follow the path, it depends only on the end point. Okay, and hence we can say delta T is equal to T1 minus T2. That means end point is a T1 and T2, and we know that T1 is equal to T2. Okay, so delta T is equal to, but it's not a isothermal process. Why? The condition of the isothermal process is not only to initial temperature and final temperature is same. Okay, remember that initial temperature and final temperature are same. That means it's not always or always isothermal process. So for this condition, so for isothermal process, the important condition is what? The temperature should be constant throughout its followed path. That means like this: if the temperature is throughout the process is a constant, okay, that means we can say straight line graph. So this process is nothing but the isothermal process. So this process is called as isothermal process. So this is the throttling process actually, and in throttling process the temperature increases and then decreases and going to the initial point. Okay, but it's not isothermal process because during this process some heat addition or rejection. Okay, and we can say it's a not a isothermal process, and hence we can say this is not a